Now let's talk about something called diffeomorphism. So in a very simple sense, diffeomorphism is nothing but homeomorphism with smooth, or so to say, infinite differentiable structure. Or you can even say it like diffeomorphisms are just smooth homeomorphisms. And the formal definition goes as follows. Let F be a map from M to N, again this is a differentiable map, such that F is a homeomorphism and let psi and phi be coordinate functions where psi if phi inverse 1 is invertible. That means phi if inverse 1 psi inverse 1 exists, and both y equals to psi, I'm omitting the circle signs, but you should understand that this is a function composition, y which is given by this, and x which is given by phi f inverse 1 sine inverse 1 of y are smooth or C infinity. Then this type of map F is called a diffeomorphism. And M is said to be diffeomorphic to N. And we denote this by this symbol. This means that M and N are diffeomorphic, and whenever this happens, the dimension of M is equals to the dimension of N. That means if two manifolds are diffeomorphic to each other, then they will have the same dimension. And diffeomorphism indicates whether it's possible to deform a space smoothly into another, and two diffeomorphic spaces are regarded as the same manifold. So if M is diffeomorphic to N, then we can say that, or we can regard M and N not to be distinguishable, rather we would say that they are the same manifold. So from this definition you can clearly see that this diffeomorphism itself is a homeomorphism. But if you ask the converse question, that is, okay, I get the fact that diffeomorphisms are also homeomorphisms, but is homeomorphism a diffeomorphism? That means if it's the converse true. Well, that is rather a difficult question, and what we can say right now is that in higher dimensions this might be the case. And you can think of asking this question as asking in ordinary calculus that if you have a continuous function, is it differentiable? Let's say at some point a function is continuous. Is it differentiable at that point? Well, maybe or maybe not, but at some point, if a function is differentiable, then it's obviously continuous. So you can think of it like that. And it is very tough, or it is rather difficult to give examples of this spaces where they are diffeomorphic to each other but not homeomorphic. And it was believed before 1956 that your topological space that you deal with admits only one differentiable structure. And in 1956, some guy named Milnor pointed out that the 7-dimensional sphere will actually admit 28 differentiable structures, and this type of scenarios where homeomorphisms are not diffeomorphism is possible. But for our discussion, we will assume that a manifold will always admit a unique differentiable structure. Okay. And before we finish our discussion on this thing called diffeomorphism, we would like to say a few more things about it. Is that this set of diffeomorphisms, the set of diffeomorphisms admit or show a group structure or form a group, and that group is called a diffeomorphic group. Which is denoted by diff of M. And you will see these things if you study high energy physics, but for now we will try to move on, and we will discuss curves and functions right now so that we can continue to develop our calculus on manifolds.